Hello and welcome to Module 6 for ED 584. And we'll go ahead and get this up for you. So we'll go into Module 6. In Module 6, the purpose is to serve as a review and to expand upon our study of t-test statistical analysis methods. In previous modules, we have examined t-test methods that are used to test hypotheses addressing group differences associated with a measured variable that is continuous data. The one independent sample t-test, sometimes referred to as the one sample t-test, allowed us to determine whether the mean, the population mean of interest, is equal to a hypothesized value, the test mean. Like all statistical procedures, there are certain assumptions that should be met to obtain valid information. For the one sample t-test, these assumptions are that the data in the population being sampled is normally distributed, that the selection of the sampled data occurs in a random fashion, and that the probability of each measured outcome is independent. Random sampling usually ensures that the assumption of independence has been satisfied. The term robustness is sometimes used to describe the extent to which a statistical method provides valid results, even when the statistical assumptions of the test are not perfectly met. The point at which the results are valid versus invalid is not always clear and may require the researcher to make informed decisions as to whether or not the analysis procedure in question is appropriate for the situation. It is worth noting that the one independent sample t-test method is fairly robust to violations of the normality assumption when sample sizes are equal to or greater than 30. Robust meaning that the method produces valid results even when the assumption is not very well met. We've also examined the related samples t-test, sometimes also referred to as dependent samples. This test allows us to test hypotheses related to differences between two populations in which a participant in one population sample is related to a participant in another, in the other sample. They may or may not be the same participant. Repeated measures or matched paired design. Assumptions are that the population of different scores are normally distributed and there is independence within groups. A more obvious assumption is that the two samples should be of equal size, as the term related samples implies. Like the one independent samples t-test, it is robust to violations of normality when sample sizes are 30 or more. One potential application of this method is the analysis of a random pre-test post-test design. And you see that here. Another potential application of this method is the analysis of a non-randomized pre-test post-test design. In other words, what would be referred to as a quasi-experimental pre-test post-test design. The design notation would look like the following. And that's what we've got here, the non-randomized pre-test post-test design. In addition, the two independent samples t-test is used to test hypotheses concerning the difference between two population means. Assumptions are normality, data in each population being sampled is normally distributed, random sampling, each of the two samples are collected through some random selection process, independence, probability of each measurement is independent from other measures, and equal variances, that the variance of each population is equal to each other. The equal variance assumption can be tested through the use of a t-test, or of an f-test. SPSS also provides a feature to test the assumption of equal variances. In cases where equal variance cannot be shown between the two groups, there is a form of two independent sample t-tests that can be used to account for this violation. There are various examples of when a two independent sample t-test would be appropriate. One of them is the randomized post-test only design. Interestingly, this relatively simple design is one of the strongest in terms of internal validity. So here's what you have with the randomized post-test only design, how that is set up. Hypothesis testing using t-tests represents a way to compare means between two groups when the data being collected is continuous data. Point estimation and confidence interval estimation is an alternative method that allows us to estimate population parameters within identified bounds based on a desired probability level. Hypothesis testing using two independent sample t-tests and the alternative point estimation and interval estimation approach are important to understand. So here are the objectives and the directions. The first thing is to review the module objectives and scan through the module in its entirety. Then this next thing, presentations, reading and supporting material, and that's where we go. And this is where the review is going to come in. And let's think on the fact that t-tests can be used in either experimental or non-experimental situation. They actually can be used in other data collection and quantitative type surveys. In the case of experimental research, we're concerned with making causal claims. The populations being investigated are hypothetical and based on random assignment to groups, with one group receiving one form of a treatment and the other group receiving another or no treatment at all. And that's a comparison or control group. In this case, these groups represent hypothetical populations, and equivalence of the groups has been ensured through random assignment to groups. A two-group post-test only design is a very good candidate for the use of the two independent sample t-tests when examining causality. So here you go. There is that two-group post-test. A non-experimental design can be used to compare and examine real populations to see if they are different from each other. Causality cannot be established, but we can establish if the groups are the same or not. In a non-experimental design, we take a random sample from each real population and then compare these samples. It is through random selection and random assignment that the inferential statistical procedures we're examining allow us to validly infer our findings to that of the population and help to establish external validity. That is to make claims about populations from our sample data. Ensuring random sampling or random assignment does require work by the researcher to establish a protocol of some form of randomness. Experimental designs are based on random assignment, which ensures randomness and are good candidates for the use of the t-test when comparing two groups. Quasi-experimental designs, a form of causal research design that does not rely on upon random assignment, but rather uses some form of convenience sample or intact group, can also be analyzed with the t-test. Although these types of designs can sometimes require more sophisticated approaches to statistical analysis than the t-test. Thus, sometimes there are trade-offs. A researcher can invest the time into a research design that ensures randomness and then be able to use fairly straightforward methods of analysis, such as the t-test. Or they can choose to use convenience sampling, quasi-experimental designs, which might require more work put into the statistical procedures. Consider your own research interests. Consider groups that might be investigated and compared. Consider the variable to be measured and reflect on the level of measurement the data must be in order for it to be appropriate for the t-test. In review, there are 4 levels of measurement. They are nominal, ordinal, interval, and scale. And so for the readings for this, it's just a review from the statistics for the behavioral sciences. chapters 9, 10, 11. How to use SPSS, and this will be a review of the independent samples t-test. That's section 6.3, and then Appendix A on effect size. And then for the assessment, what you'll do, you can click here for the reflected commentary, and then you can go ahead and begin work on assignment 2. Here is the link to get to there. And this is not due until March the 6th. And this will be divided up into 2 parts. Part 1 will be similar to assignment 1, where you'll go in and answer questions from chapters 8 through 11. And then part 2, you'll use SPSS or a statistical calculator to conduct a 1 sample t-test and also a 2 independent sample t-test. And then your data set has been attached that you can use in order to conduct that statistical analysis. And that concludes the introduction to Module 6. Thank you.